is going to be about CDC pipeline, change data capture pipelines. Now that pipeline is tailored for a use case in finance. So for a finance domain, how should we design CDC pipelines where accuracy, latency are non-negotiable parameters? I'll pass mic to Sujit. Sujit is working with Sahaj for, I guess, last 2 years. He has total experience of 14 years where he has developed multiple cloud native applications, developed multiple microservices architectures. He has also experience of doing functional programming. So he's a great leader at Sahaj, and I would like him to go through his talk. So Sujit, on to you.
Cool. Can you hear me? Cool. Thanks, Shruti, for introducing me. So apart from the things Shruti mentioned, both the boring stuff she mentioned about tech and all, apart from that, I also am into music. I'm a guitarist myself, and I do like to listen to metal music. And recently, I also started learning sitar. So that's about me. So we'll start today's talk. So it's more about my first-hand experience of putting up change data capture in production and making sure it runs without any issues. So the talk is going to be more about personal experiences and learnings which came out of that journey. It would be less focused on tech as such. So let's get started with that. I hope everyone had a great lunch. And I just don't hope that the scene looks like this after some time. Yeah. Now I think about it, if I knew that my talk is going to be after lunch, I would have got my guitars, just so that to make sure everyone stays awake for the entire duration of the talk. But yeah, with that out, let's get started. So in today's talk, we are going to, I'll be briefly introducing what was the use case, and then we'll talk about what exactly is change data capture, also known as CDC, and how did we implement it, what were the practical challenges, possible solutions for those challenges, and the learnings which came out of it, which might be beneficial for anyone who is trying to do the same in their projects. So this is the use case we had. This is for a retail bank. So many of you might already know that in a bank, the customer data is very segmented, right? It's very fragmented. Data is stored in different source systems. For example, you have a separate source system for saving accounts. You have a separate source system for loan accounts. Your Forex data is in a different system. Credit cards are in a different system. Your customer information is in a different system, right? There is no single place where you can get the whole or 360 view of the customer. So the use case is to build customer 360 platform where basically one can bring data from all of these source systems into a central place, and then you get the 360 view of the customer, and you can do a lot of cool stuff about that data. So you can draw a lot of insights based on the customer data. You can build personalization engines. You can give personalized offers based on the data. You can do fraud detection. And there are many more insights which can be drawn from the customer 360 data. Also, the same data can be used by different channels like net banking applications, chatbots, UPI, FASTag. There are many such use cases in a bank. Cool. So this was the use case. And this is a problem statement: build a customer 360 platform for a retail bank. Although they already had a 360 platform, which was a legacy platform. This was more of a revamp that into or modernize it. Some of the key goals for this program were we wanted to have faster and consistent response time. The one constant issue bank did mention was their logins were very slow. The net banking logins used to take upwards of a minute, and any customer might get frustrated, right? Even I would get frustrated if I have to wait for a minute just to log into my net banking. And since this platform was going to be used by any other subsystem in the bank, the APIs needed to be faster. Update should be reflected near real time. Anytime there is any data changing about the customer, be it new credit card bought or a new account opened, that needs to be reflected almost near real time so that customer doesn't have to wait till the next day to just access his newly opened account. And also scale to the growing volume of the data because the bank was in the growth journey. I can't reveal the bank name, but trust me when I say it was in a growth journey. It's one of the biggest upcoming banks in the Indian market. So these are some of the stats when we started the project, and obviously these numbers would have changed by now. This was, I think, 2019 or 2020, I guess. So we had 90 million plus records in the database or in the bank. This included customer records and accounts as well. We were adding 2.3 million plus new records per month because the bank was in a growth journey. New customers were being onboarded. We were getting 10 million plus requests per day onto the platform, 250 plus attributes per entity. The reason to call this out is because, if someone thinks of a customer data, basically what comes to your mind is basically there might be only few fields, right? 10, 20, 30. But this was such data that it had upwards of 250 plus fields. And there were a lot of big text fields like addresses. Anyone who has worked in a retail bank kind of a domain would know. Each customer, there would be 4 to 5 addresses, each address having 4 to 5 lines and so on. So the record size was huge. The volume of the data at the point when we started project was 270 plus GB. So we started doing legacy model transformation. Before I talk about how did we do that, what were the key problems with the legacy system and why did the bank want to basically rewrite their key platform or the core platform? So the challenges were they had used a proprietary tool which was based on stored procedures to build a master data management system. And obviously, since it was proprietary, it was very expensive. Every year they would have to renew it, and it was costing money. That was less of a problem. The bigger issues were it wasn't scaling up. Scalability was a problem. With growing number of customers, it was getting more and more pressure on the system, and it was responding slow. Response times were slower and were very inconsistent. Sometimes it would take up to a minute to respond for the API. Sometimes it would be in seconds. And also development effort-wise, making any change to the platform used to take a lot because the system was very complex. It was based on stored procedures. It was very bug-prone because most of the logic was written in stored procedures. Figuring out what are the issues, problems, debugging, fixing, the turnaround for that was also pretty high. So like I said, they already had a legacy master data management system and they were getting data from their source systems into a central place called as master data management. This was already in place. So when we wanted to do legacy transformation, what we decided was instead of trying to replace their ingestion mechanism altogether, maybe let's start with a smaller approach or an evolutionary approach where we'll replicate the data from legacy master data management system into a new storage and we would expose it over a low latency API. And then slowly we would phase out all these ingestions from these source systems to directly write into the new database we introduce. Now you might see there is a database on the screen which says Aerospike. It's a distributed key value database. It scales up to petabyte kind of volumes and It's a low latency database. It's a very interesting database if anyone hasn't explored. It works on hybrid memory architecture, very fast, sub-millisecond kind of read response time. Pretty much every other startup in India is using it. I already have a talk on that on my YouTube channel. You can go check that. Uh, so I'll not go into the details of Aerospike anyways. So we chose Aerospike as our database. And then we wanted to replicate data from legacy master data management system into the newer database we have selected. So that's where our journey began. And then obviously we exposed this over a low latency API, which would be consumed by different channels. The very first channel we onboarded was the net banking application, both mobile and web-based net banking platforms. Yeah. Cool. So yeah, so what exactly is change data capture? We wanted to replicate data between source and our database, right? How do we do that? So let's talk about what is a change data capture. Change data capture basically means exposing data as a stream of events, right? So whatever data is there in source or whatever changes are happening in the source database, exposing it over as a stream of events so that downstream system can consume it, process it, store it, analyze it. That is what is called as change data capture. So let's talk about what all are the typical use cases for change data capture, right? The very common use case is to replicate data to other databases or feed into analytics systems, be it Spark, Flink, or whatever is your tool of choice. You can get that stream and do the stream processing and draw insights from that. Or you want to feed data into other products, that is another use case. Or you want to create a data warehouse and feed your data into that. That's another use case for change data capture. The other set of use cases for change data capture is in the microservices domain. So if you have a big monolith and you want to extract microservices, it's a very common pattern that you would start replicating a portion of the data from the original monolith into a new database, write a new service on top of that. All of your writes will go to the legacy system and reads would go to your new microservice. That way you are still able to bring in improvement to the legacy system without breaking anything. And slowly you can just phase out all the modules and then also start writing into the newer microservice. So it also helps there because all of your writes are still going to the legacy system, but since the data is getting replicated, you are able to get the benefit of faster reads. Other use cases for change data capture are auditing. If I want to know anytime I write a data to a table and I want to capture what was changed, you can apply change data capture there because it basically publishes what was the before data and after data, and then you can just decide to, let's say, dump it in S3 or wherever you want to. You can use change data capture to also populate caches, or if you want to build a search index on top of your data. For example, in e-commerce, there is a very common use case of product catalog or product search, which generally doesn't work very good on a database, even if it is a document database like MongoDB. So the better approach is you basically index the data into Elasticsearch and then use that for faceted searches. So the change data capture will also help you there because you can very easily populate your Elasticsearch index using change data capture. And if you want to enable streaming so that you can do some things, that is also another use case for change data capture. So now we talked about what is the change data capture, what all are the use cases, but how do you do or how do you replicate the data? So there are a couple of options here. So the very first option is dual writes. So consider you have a microservice and you are writing data to a database. At the same time, you want to publish it to a Kafka topic. The very basic option is basically you write in both the places from the application, right? So that's very low effort kind of an approach, but there are problems with that. Anyone? So there are problems that now your application layer has to know about two things, which is database and your streaming or message broker. And tomorrow if you want to write to a third place, then your application logic is getting polluted with that. The other problem is transactions, because it can happen that you have written data to the database, but you fail to push the data to Kafka. And then if it is not in a transaction, rather you can't have it in a transaction, it will go out of sync or your data is not consistent. There are different approaches to handle that, like distributed transactions also, which adds additional complexity. The second approach is, or second class of change data capture tools use polling based mechanism. What that means is you can continuously poll the database or database tables and see if there are any changes happening in the data. And then if there is a change, you would basically push it onto the message broker. But the challenge here is how do you detect changes, right? Right out of the box, you can't, there are no mechanisms for you to basically detect changes, right? So then you have to do things like add a timestamp column in the database table and then see if it is changed, then get the data, push it, and so on. Handling deletion is also a challenge because if the record is deleted, you won't know because it doesn't exist in the database. And the latency is also higher because you are continuously polling database. It puts more pressure on the database. Also, the interval which you have configured to poll the data, based on that, the latency to replicate the data can also be really high. Then there is a third class of change data capture tools called as log-based CDCs or log-based change data capture tools. How do they work is every database generally would maintain a transaction log. So the transaction logs are typically used for in case if your database goes down and it has to recover, it can use transaction logs to recover from that. Or if you want to replicate data between your primary and secondary, even for that, transaction logs are used, and that is the reason most of the databases would have some kind of a log mechanism in place. So what if we could hook onto those transaction logs, and anytime there is a new entry in the transaction log, that is a new event, right? So these log-based change data capture tools work on that principle. So they would continuously read the transaction logs, and as soon as there is any new entry in the transaction log, they will push it to the messaging broker. And then from there, you can consume the data and you can decide to do whatever you want to do with it. In our case, we wanted to store it in Aerospike. Yeah, like I said, different databases have different kind of transaction logs. For example, PostgreSQL has write-ahead logs, MySQL has bin log, and so on. Oracle has redo logs, which many times you have to enable. Sometimes they are not enabled by default. Cool. So in this example, so basically it's trying to explain how the change data capture works. So as on the left hand side, you can see there is an insert, update, and delete operation happening in the database. For those three operations, there will be 3 entries made in the transaction logs. And then change data capture would basically see those entries and would push them onto the messaging broker in the same order as they happened. So it will not go out of order in terms of those events. And then the consumer would process it, and then the data would be replicated in the Aerospike. So in the target database, as you can see, 1 record is inserted, 1 record got updated, and 1 record got deleted. So that's the basic idea of change data capture pipelines. These are some of the open source, not open source, these are some of the change data capture tools. Most of them are not open source, except for Debezium, I think. Debezium is the open source one. Many of them are proprietary, which means you have to pay money for that. Apache NiFi is again free, but it doesn't work based on the log-based change data capture mechanism. GCP also has a new offering called as data stream. Cool. So now we saw what is change data capture, how it works. So we'll take a look at our journey of implementing that and taking it to production. So to begin with, we started with Oracle Golden Gate because our database was Oracle database, and bank happened to have a Oracle Golden Gate license. So we started development with that. We went till UAT, and then we realized few things. So there were few challenges with the Oracle Golden Gate. First thing, it was expensive, and it's very expensive. Someone who has seen the costing of Oracle Golden Gate would know it's damn expensive. The throughput was also very less. The problem is Oracle Golden Gate is not a distributed system as such. So to push messages from the source DB to the Kafka, it would take more time. This is especially problematic when you want to do initial data load, that is replicate existing data into the newer database for the first time. Observability was also a problem because it's a proprietary tool. It doesn't come with its own observability. It runs on a Oracle server. So unless someone goes and sees what's happening with the connector, no one will come to know, if it is running, not running, or what's going on. So then we went to UAT, and then we decided to replace Oracle Golden Gate with Debezium. Debezium is an open source change data capture tool. It works, it's basically, again, it works on transaction logs itself. One good thing about Debezium is it's a distributed system. It works on a distributed framework, which means you can spin up more number of coordinator nodes, and it would basically push more amount of data. So the throughput would be better. Also, it's a low latency system. Our requirement was to get data in like sub 200 milliseconds. What we had seen was replication was pretty fast, less than 20 milliseconds, end to end. This is end to end. It works on a Kafka Connect framework. You guys might already have used Kafka Connect by now. And Kafka Connect on its own is a distributed framework, right? Debezium basically works on Kafka Connect, which allows you to scale your pipelines. These are some of the source connectors Debezium provides, and it keeps on adding support for new and new databases. So support for majority of the RDBMS is already there, like PostgreSQL, MySQL, Oracle database. Support for NoSQL DBs like Mongo and Cassandra is also there. And they keep on adding. I think some of these are still in incubation, like I think Google Cloud Spanner is still in incubation. So they keep on adding support for more and more databases. This is a Debezium deployment topology. So it's typically deployed in a Kafka Connect framework, which is a distributed setup. It would have a coordinator nodes and scheduler node. Yeah. And then it would push data to the Kafka, and then you can use a sync connector and push data to Elasticsearch. So because it works on a distributed framework, you can very easily scale your pipelines, which was not the case with other connectors or Oracle Golden Gate. This is a typical message structure of a message which is on a Kafka broker, which is sent by Debezium. So for each table, it would push data into a different topic by default. and then by default it will use the primary key of the database as the partitioning key, right? And you can change that if you want, if you really want, which means your events are also ordered, meaning if you update the same customer multiple times, you would get those events in the same order. So ordered processing is also guaranteed. In the payload or in the message, you can see there are different sections. In the payload, you can see there is a before and after. So it sends both. What was the data before it was changed or before a transaction happened, and what was the data after a transaction happened, right? So that if you want to do any processing based on that, you would be able to do it. In case of update, this would be true. In case of inserts, there will not be any before, there will only be after. And in case of delete, there will not be any after, there will only be a before payload. It also sends you optional schema payload. I have skipped it for brevity. So it will also tell you what was the schema of your database table. And if there is a change, you would be able to figure that out. Since our database, target database was NoSQL, for us it didn't matter because schema doesn't matter when it comes to key value databases. And there is some additional metadata. It talks about what is the table, what is the database, and so on. So Debezium helps you do both. Like I mentioned earlier, you can also do initial load and incremental load. So anytime you set up a change data capture pipeline, the very first concern before you go live is, how do you make sure you have migrated existing data into production? And then obviously there onwards, it will go into an incremental mode, meaning for any new data which is being written, updated, deleted, it will generate those events, and then they will be there in the Kafka. But how do you get the initial data, because it has already been written? And maybe it has been written over multiple years, right? Like 5 years, 10 years, you don't know. And in that case, you won't have transaction logs of all those years because they would be cleaned up. The transaction logs do take a lot of space and they are frequently cleaned up. Meaning you won't have transaction logs of your historical data. So then how do you, push that data to the Kafka? So what Debezium does is it takes the snapshot when it starts for the first time. It notes that it has started for the first time. It will check the Kafka topic. It will see the offsets and it knows that this is a new connector it has started. The first thing it does is it will do the snapshot. It takes the point in time snapshot of the database. And then from that snapshot, it will start pushing data onto the Kafka topics. Once it is done pushing data from the snapshots, it will go into the incremental mode. And then first thing it does is it will push any pending transactions between snapshot and till the time it ended up pushing all the data from the snapshot. It will push that data first and then it will start listening if there are any more transactions in the database. Cool, so the benefits of Debezium over Oracle Golden Gates are it's scalable, low latency, it provides observability since it works on Kafka Connect framework, which has a great support for observability in the first place. And there is no additional load on the database because it's a log-based change data capture tool. Cool, so we implemented that, we replaced Oracle Golden Gate with Debezium, and we had to do certain changes because the payload structure was not same, etc., etc. And then the first thing came before going live is, since we were dealing with very critical finance data and there was no margin of errors, any mistake was not acceptable. The first thing we wanted to see was how do you make sure the data is consistent. So the hardest part of implementing change data capture is to make sure it runs all the time. That's what I have learned from this project. Implementing change data capture is very easy. Maintaining it, making sure it runs all the time in production is very difficult, said someone. So then we started designing a testing strategy. How do we test if the data in source and destination is in sync or not? So the first set of tests we did was we had table level and column level checks where we counted how many number of rows are there in the source and destination and compared them, right? And if there are any, we also compared the duplicate record counts based on primary keys. Also, for each column, we had certain checks in place, like number of nulls, number of not nulls, mean value, max value, percentages of true, false, etc., etc. So to be able to do this, we had to do a few more things because since we were using NoSQL database, you can't fire such kind of queries. You can't just say, give me count of this or count number of nulls because the data is distributed in multiple nodes, and these kind of queries would be very slow. However, our source database was RDBMS, so that was not a problem. So what we did was we introduced something called as Trino. You must have already used it. Trino is basically another distributed system. It's a distributed SQL query engine. What it allows you to do is it allows you to use SQL as a query language, and then it would be able to basically take that SQL and distribute the SQL query into multiple smaller queries and then fire it on the target data source, get the data and return it to you. So basically it's distributed in nature. It works on any kind of a database, not just RDBMS. There has to be a connector support for the database you want to hook. Thankfully, Aerospike has a Trino connector available, which means you should be able to run SQL queries using distributed query engine, and that helped us. Superset also comes with, by default, it comes with connectors for common RDBMS databases. But since we had Trino, we just used Trino for both. And then we built a dashboard in Apache Superset with all those checks. Apache Superset is basically a visualization tool where you can build different dashboards to analyze the data. It's an open source tool. This is how a typical dashboard looks like. This is not our dashboard. Just wanted to show a sample of a Apache Superset dashboard. Cool. So we started with those data checks, and then we realized, okay, the checks are not matching, like the data is not matching, the counts are all over the place. Then we started going into what's happening. So the first thing we did was get the row counts to match in the first place, and then started going into the issues like, oh, the dates are not matching. And then we realized there are different problems with the way we are processing the data. For example, when you apply a change data capture on any database, the time zone of the database also matters. So our source database was in IST, Debezium was in UTC, and the consumer was in UTC. And we were assuming everything is UTC, and all the dates were all over the place. That was one of the problems. So you have to account for those things. Also, for the Oracle, based on the different precision of the date, it used to convert it into microseconds, milliseconds, or nanoseconds. This we realized very late when we started doing these checks. And we were assuming that everything is nanosecond. And then we would have data in target database which used to say, oh, account expiry date is 16 Feb 1975. Whereas it was 7 April 2021. So these kind of misses are very difficult to spot unless you don't have those kind of checks in place. That really helped us figure out these issues. So over the time we fixed all those issues, we felt confident and we decided to go live. We did thorough UAT testing, we did performance testing on a realistic volume of the data in a performance test environment. We also onboarded the net banking, mobile banking application as one of our first consumers, and we were ready to go live, which means starting next day, every customer of that bank was gonna, their call was gonna be received on our new platform. So obviously we were awake late night That's how any Indian bank operates. Yeah, the next day looked like this. So Twitter was full with all sorts of complaints. Support people were going crazy. They were receiving tickets like, oh, I'm not able to log into the net banking. I can't pay my credit card bill. I'm not able to see my account. My account has disappeared. Uh, and everyone was panicking. And obviously because for any financial bank or retail bank in India at least, RBI is very strict when it comes to such kind of issues. Anytime if you are not able to log into to your net banking account, or if you are not allowing customer to use their own money, the bank is penalized very heavily. So the RBI is very strict in that sense. So we had to act fast on this, and then we started looking into what all are the problems. What are the problems? Why is this happening? Because this didn't happen on UAT, or this didn't happen in lower environments either. So we saw that the connectors, Devism connectors were failing after every few days. And then we were not able to come to know that the connector has stopped. And there is a loss of data, like the data replication was stopped. So we had to manually restart the connectors to bring it back and then reload the data. Now figuring out the data mismatch is also a problem because our target database was a NoSQL database. So it's very difficult to figure out what data is missing from target database. So then we started doing full loads, like every night or every other night, someone would basically would create a new connector. It would do the snapshot and start pushing the full data in a hope that it fixes some of the customer issues before the next morning. So the challenges were there was no visibility into connector failures. Connectors were needed to be restarted manually. And the full data load also took time. One of the biggest data was accounts. Customer data was not that much, but accounts data was huge. It used to take around 18 hours, even with Debezium, to load the entire data. And meanwhile, customer support was taking care of tickets by manually pushing those records. So if they would receive a complaint, they would go to that customer and they would push all the records of that customer manually by doing dummy updates to the source database table. So that's how we kept it under control somehow. So then we started figuring out what went wrong. Debezium was not at a fault. Earlier we thought, okay, Debezium is the problem. And then we also explored other options of getting enterprise support for Debezium from Red Hat. Because Red Hat is the company which basically promotes or sponsors Debezium. So the issue we found was the Oracle database in production was under huge flux. It was one big Oracle rack which was used by all the source systems in the bank. And since the flux in the production is huge, like every other customer is doing something, right? Whereas on UAT and QA environment or performance environment, it's only developers and QAs who are doing some testing, which is not enough kind of a flux in terms of data. Although we had tested everything on realistic volume on lower environments, but what was missing was the flux. And because there was a lot of flux in production, Oracle was generating huge amount of redo logs, the transaction logs we talked about. And then we had limited storage, obviously. It was already in terabytes and it was getting consumed. So Oracle would just clean up the older redo logs. So more the load on production database, it would clean up the redo logs. As soon as the redo logs are cleaned up, the Debezium connector which was listening to that particular redo log would just crash without any exception. It would just stop. So it was getting difficult to figure that out. So first thing we decided to do was improving the observability into this. Since we did change to Debezium a little late in the game, meaning after all the development was done, we were almost in UAT. We kind of paid a less attention towards observability when it came to Debezium. We already had observability in place for our application, which is consumer. We already had observability in place for Kafka. We were monitoring Kafka lags. We were monitoring throughput. We had observability in place for Aerospike as well. We were using Prometheus Grafana, and anytime there is a problem, the alert would be sent to a mobile device of a support person using PagerDuty. So then we also implemented observability for Kafka Connect. And Debezium also has a support to push certain metrics to Prometheus. So then that's how we started getting those metrics from Debezium. And then we created dashboards on top of it, and we also implemented alerting so that we would come to know when the connector stops. So this allowed us to detect connector failures early on. We still needed to reload subset of data because there would still be some time between the connector stopped and it gets restarted. And then the issue is still there, right? Like you are still losing some data, although it has you have got more visibility into the connector failures. The problem is still there. The manual restart of the connector was also painful. There was one person from the bank side who was managing connectors, and then if that person goes on vacation, then that's a problem. I remember one day he was in his wedding. Even on that day, he was trying to support this. It was kind of crazy. And the frequency of connector failures increased over a period of time because what happens is for any bank, right? The AC stopped or something? Cool, I'll continue. So the frequency of connector failures increased because what happens is the salaries are paid in the last day of the month or the first week of the month. Credit card bills are to be paid during that period. So the flux of the data is more because the load is more during that period. And then we started seeing more problems. And the end of the day, data reload was also not a sustainable solution because it used to take a lot of time. So then we still wanted to fix that problem. How can we make it reliable, right? And we also reached out to Debezium support people, Red Hat people, and they were still not able to solve the problem for us. So the only option was to basically figure out any other fallback mechanism which would help us in fixing these issues. So what if we could build a solution which detects missing records between source and destination and pushes it automatically and also do it very frequently. So one doesn't have to wait till the end of the day or end of the month before doing that. So then we started with that and we started designing a data recon tool or data reconciliation tool. Is the tool we wrote ourselves from scratch. So we already had Trino in place, which allowed us to query both Aerospike and Oracle. So what we did was we did certain changes in the way we were replicating data. What we started doing was we started capturing timestamps in Aerospike for each record, when it was updated, when it was inserted. Likewise, even in Oracle, we started doing that, which allowed us to figure out what all were the records which got changed during what time period. And then we wrote a job. So this used to run as a small cron job. It would trigger every few seconds or every minute. It would basically make a query. It would see what all are the transactions in the last minute, and are those transactions replicated in the destination. And if there were any missing records, it would basically just re-push those records manually onto Kafka in the same format which Debezium was using. That way we didn't have to, basically the same consumer worked because the format was exactly the same. And this works because otherwise it won't work. There would be certain edge cases, right? For example, data in source got changed in like last minute, but when the cron job ran, it ran in the next minute, and then basically it would think that the update was in a different time frame, and then it would say that it is a missing record. It would re-push that record twice. That was not a problem for us because the way we had written Kafka consumers were idempotent. What that means is even if you process the same record twice, the end state of the system doesn't change, it remains the same. This helped us manifold because even if you do the data reload, even if you push the same record, since the data is same and the consumers are idempotent, there is no change in the target system. Whereas if the data is missing, it would just go ahead, add and insert the data, right? And we started doing this more often. It used to run every minute, and that kind of solved most of the problems for us. So there were no more failed logins. The number of complaints got reduced, number of customer tickets went down, and then we also automated the connector restarts. So instead of a person, just trying to restart it manually, we wrote scripts for that. So whenever it used to stop, it would basically start it again. And then we also had another fallback mechanism, which was do a full load at the end of the month, just before the peak period begins, which is credit card payment duration and salary kind of that period, which is end of the month and first week of the month. So with that, these are some of the learnings from our project. So how do you make your change data capture pipeline bulletproof? In the first place, if possible, don't do change data capture. So basically what that means is your data volume is very small. You don't really need a change data capture. Maybe you would need some different mechanism, right? You can go for polling based change data capture, or you can do batch. You can have a batch job to basically load the entire data at a frequent interval. But if at all you go with change data capture route, because for bigger volumes, those solutions won't work, expect that the change data capture would fail, and it always fails. Whatever tool you want to use, it is going to fail. Be prepared for that from the day one. Understand your data volumes. This is true for any kind of a data project, not just change data capture pipeline. If you don't know data volume you are dealing with, you won't be able to build system as per that. So understand what's your current data volume, at what rate it is gonna grow, and make provisions for the same. Test not on just the realistic volume, but with realistic data flux. This was one of our biggest learnings. Try and make sure your consumers are idempotent. That helps you in many ways. Build visibility into data consistency issues. Just because we had those checks in place using Apache Superset, we were able to figure out those issues. Otherwise, until and unless a customer doesn't complain, no one will come to know. So having those consistency checks in place is really important. Build observability at every component, be it your source database, Kafka Connect framework, consumers, target database, any smaller component, have some observability in place for that, just so that you would come to know if any component goes down. Because it's very expensive to restore data when any of this component fails. And just in case if something happens to change data capture, be ready for it, have some fallback mechanism in place. In our case, there were multiple, like we had alternative way to sync the data. We had other mechanisms like full load, or simple things like changes in process where tech ops person can just go and update records, and that flows manually to the target database. So have all of these things in place so that you're ready for the disaster. Cool, that's about it today. Any questions?
We have a question.
Hi, it was a nice session. My question is around the.
Sorry, can't hear.
Yeah, hi, it was a nice session. My question is around the encrypt.
Can you be a louder, please?
Yeah. My question is around the encryption of data, right? In Oracle, when you store, like we saw the other use case where he was talking about the advertisement and consumer data coming in. He talked about the abstraction at which you really want to consume the data, but at some point of time, he would be storing some proprietary data which needs to be encrypted at the database storage because it's in the cloud. So all that encryption logic really sits in the application layer, at what key you're using for your application for encrypting. Now, when you write that encrypted data into the logs, again, that will be a problem. So I think transactional logs will not really decrypt your data and write it because they don't know the decryption key. So log-based approach, when it takes that encrypted data, goes through the Devisium and it comes to the Kafka to the consumer. And you also talked about every table becomes a topic. So in consumer specifically, do you have a logic which listens to every topic, understands that topic is mapped to which table and which column contains the encrypted data, and you then use the decryption key into the consumer, and that's how you push the data into Aerospike?
Okay. So the question is how the encryption is handled in a nutshell. Because when it comes to sensitive data, sometimes people encrypt the data and then store it into the database. And there are different techniques based on sensitivity of the data. Sometimes you just mask the data. You don't really need to encrypt the data. You just basically, or sometimes you tokenize the data, right? You store the data in an external system and store a token for that in the database. What we had was a tokenized data, not encrypted as such. Another thing is this system didn't deal with financial transactions, meaning let's say if you debit amount from your account or credit amount in your account, there is a different source system which takes care of it. Where those things would apply, your encryption is taken care at each field level in the database. However, we had data in mask form and in tokenized formats, which was not a problem for us. I also wanted to talk about something.
Yeah. However, let's say if this is not, it was not a use case in the problem statement which you solved, but had this been a case in one of the columns where you have encrypted data, will the logic really reside in the consumer side? Then you have a decryption key which is pretty much known by that consumer and then decrypt, because there is no other place, or you use Kafka streaming at some point to do that.
Yeah, I think definitely you would need a mechanism with which you would be able to access that key, just so that you can decrypt the data. We didn't have that use case. What we had was encryption at rest at all the layers, basically source database, Kafka, target database, and encryption in flight. But the data itself was not encrypted in our use case. But for those use cases, I think someone has to find that mechanism where you can share the keys between these so that you can decrypt the data.
One question I have on the solution which you implemented for data recon. You talked about you added a timestamp column. So was it added across all the tables, because every record precisely needs to be a recon? So did it went through a massive change in the data structure of all the tables, adding extra column of timestamp?
Yeah, so it was not all the tables, whatever tables we were replicating, but yes, you're right. And it was not a massive change as such, because target database anyways was NoSQL, so there was no schema change. We just started writing a new field, right? And source database, we just had to basically add those columns, which is not a big deal as such.
Yeah, but for the older record which were already existing, you would have added some dummy timestamp and migrate.
Yeah, we didn't need timestamp there because it was being taken care by initial load.
Aren't the companies who create the databases incentivized to make good CDCs?
Okay, the question is, can you repeat the question again?
Are the database companies incentivized to make good CDCs or bad CDCs? Because technically you're taking the business away.
Okay, that's a good question. So Oracle, right? Oracle being a database provider has their own chain data capture, but they will charge you a hefty amount of money. In exchange, you are getting maybe more stability because they know their database well, they would be able to give you a better tool, right? But you end up paying more money for that. And also, that doesn't guarantee that that tool will never fail, because database itself is such a thing that it's very unpredictable. There are a lot of operational things which are happening, like cleaning up of transaction logs, which no one has control over. It also depends on how the customer is using the database. What is the deployment topology, how they are maintaining it, what kind of processes they have got, what kind of a cleanup policy they have got, what kind of a replication policy, backup policies they have got. And things can go wrong in all of these, and then the connector would stop. Although I agree that a connector made by a database company would be robust than a open source connector. Yeah.
Hi. That recon mechanism that you added, won't that add extra load on original DB?
No, generally it doesn't. It just listens to the transaction logs. So you're talking about Debizium, right?
Yeah.
Yeah. So the question is, does it add additional load on the source database?
Not just Debizium, that recon mechanism also.
Yeah, okay. So there is a difference between polling-based change data capture mechanisms and the data recon tool we built. It used to run in a very short duration of 30 seconds and a minute, and it would only query data in that period, which was very small data. So although it was a little bit more load on database compared to transaction-based log capture, change data capture, but it was not as much.
Okay.
So it didn't cause any issues for us as such.
Okay, thank you.
Hi. I'm sure that you might have had had to be really pragmatic in order to choose, right, what is important for the end customer, because
Sorry, I'm not able to. Can you increase the volume
Hello?
of that mic, please?
Hello? Am I audible? Yeah.
Huh.
Yeah. So I suppose that you had to make choices about what you want for your end customers, right? On one hand, imagine the same database was just replicated and a read-only instance was used, right?
Yes.
The customers would have had everything, but probably slightly slower.
Yes.
They would not have that sub-millisecond timing that they are looking at.
Yeah.
So I think you had to make a choice between
Yes.
whether I go for the same database, but then all this would have been avoided because the database itself is doing all that application for you.
Yes.
Right?
Yeah, you're right. So this was a Oracle DB, right? They already had a replica of that. Obviously, any bank, that's a RBI compliance thing, that you have a primary, you have replica of it. In case of failure, you will fail over to that database. Now you can very much use that as a read replica, right? But the problems are still there with the growing volume of the data. That solution is not going to sustain. Latency issues would still be there. The database would still respond slow to the queries, right? Also, the APIs which were written on top of that would suffer because of those SQL queries. So temporarily that solution would work, not in long run. And bank obviously wanted to solve the problem for long run. So that was not a acceptable solution. That's a cheap solution which one can implement.
Maybe with your solution, I can see that response time is really great. But is it not the case of when getting into vendor lock-in?
Aerospike, you are saying?
And also that CDC is with you, right?
Change data capture.
Yes.
Debizium. So Debizium is an open source tool anyways. So okay, most of the components in that pipeline were open source, right? Earlier we had Oracle Golden Gate, which also was removed.
Right.
We use Debizium, which is open source. Kafka Connect is open source. Kafka is open source. And other ecosystem which was used for consuming the message is also open source. Aerospike is a proprietary database. However, there are multiple versions of it. One is enterprise version, the other one is community edition version, which is open source. But we use enterprise because it came with special features like encryption at rest and other features which are mandatory because of RBI compliance. Now you are right that bringing in that database means there is some kind of a vendor locking, right? But that is true with any other database, right? Like even if you go for, let's say, an open source database like Cassandra, some point if you face an issue with Cassandra, you would have to anyways replace it. So yeah, I mean, that was kind of a trade-off that it's okay to pay more, get a database which works for us, and then let's see what happens.
Okay, thanks.
Thank you.